Greetings, welcome to your Punctibyte for this rainy Sunday afternoon, headed into the last week of September. Let's take just a moment to go through some scheduling notes and take a look at what we have up and coming. We've got labs 7 and 8 this week, and also we have a couple of due dates coming up. So on lab 7, we'll be receiving their unknown press releases, and during lab 8, we'll be receiving their dilution problems. So I just want to take a minute to look at where you're going to find the grading keys for both of those assignments. So you'll find those right here on your jump drive, and you'll notice that there's a whole folder that is labeled grading keys. So just go ahead and click on that folder, and you'll find in here both for the dilution key and also for the unknown press release. Let's just open up the press release one. And you'll notice here that it's pretty straightforward, but I would suggest printing this off for each of your students so they understand how it was that you came to the grade that you assigned them. Very important to communicate that. You'll notice that it's a half a point each for reporting on the colony color morphology, shape, arrangement, but also the staining, the Graham reaction, acid-fast, endospore stains, and correctly identifying the unknown. We also told them the species, so we would want that somewhere to be in their unknown reports. You also have a point for creativity and quality, and that's a good place to make comments and let them know you either, really liked their reports, or maybe there was something that they could have done a little bit better on there. So this is the key for the press release. The key for the dilution problems is similar, only it gives you all of the math on that. So I'm just pulling this up as well, but I did want to make a note on dilution problems and dilution problem grading. Sometimes what happens with this is that TAs will look at the methods that I have put forward to answer some of the questions, and maybe not think about the fact that certain of these questions could be answered in more than one way. And uniquely, I'm tending to talk here about questions 3 and 4, where any scheme that works is actually worthy of credit. But I do often like to make a note to them to just say, hey, this scheme works, but you could have gone about this in a lot easier way. And then maybe you'll show them how they might have done it using factors of 10 or factors of 100. So this is the key that you'll want to tap into to use, and being consistent on that grading. It's also a really good idea to find a good way to come up with how to distribute points. Maybe you'll go ahead and give a point for each individual little facet of a problem, and then you can multiply by the total, multiply a percent by the total, so that it's easier to set out for those grades. Let me know if you need help with this, or let one of your older TAs, if you happen to be a new TA, give you pointers on how to go about dilution problem grading. So those are the two up and coming due dates that we're looking at, and we'll pull back up our schedule here and just take note again that there are some other up and coming scheduling things. This Friday, Josh and Andy and John are going to be responsible for Open Lab, but I also want to call your attention to a future Open Lab. You'll notice that coming up here on the 11th of October is a day that I actually have to be gone, and I know it was sort of a strange happening of events that Kyle also happens to be scheduled for this lab. He too will be gone. So what I need to know is if anyone is available. So jot a note now to email me if maybe you can cover Open Lab on the 11th. I will make sure to have a supervisor there, but it doesn't hurt to have extra TA help because you guys are the ones who truly know what's going on. So I want to have as many of you there as is very possible. I also want to take note that lecture exam number 2 is up and coming. Okay, that being said, I have a couple of fun things to talk about, and then we have some more logistical things to take a look at. I want to remind you about the class Twitter feed, and if you're interested in following me on Twitter, you'll note that the virtual edge is the hashtag, and in fact it's all lowercase, the virtual edge, all one word, and that's a way that you could come in and follow those that I retweet. If you're super interested in getting the tweets that I get on my site, I can give you the login information to get in there and get all of the tweets that I get. There's been some fun ones today, and I'll just kind of run through the feed here. One that I just retweeted was a YouTube video on the central dogma, since we've very recently been talking a little bit about that. So you'll notice too, if we scan down a little ways, there we are. I've tweeted about an article that I found on the library's website, and there are some great resources on the website that the librarians have built for micro, and that's something I can show you on a different Punctibyte if you are interested. So one of the central dogma ones I'm going to just bring up, this is the YouTube, about the YouTube video, and it might be fun to show this in lab, so we might think about maybe integrating that in during a downtime, if you will. The other really fun thing is that I feel like we're finally really primed to take advantage of the students taking photographs of their slides and probably up and coming their plates and whatnot. So I actually want to show you a site that I have, that actually Chrissy has set up for us, that has the Flickr account, and students can actually literally send an email to this Flickr account. So they can send their photos to this Flickr account, and if they send their photos to this Flickr account, then it will post them, and we can actually start accumulating student virtual contributions. So that could be really, really fun. I will have this addressed, but if you guys can remind me to let the students know that this will be a really great way for us to start to accumulate class photos, and also to share them, because sometimes that might even help students who are struggling. If somebody gets a really good slide, they take a photograph of it, and then other students see that online. They're like, wow, how did you get such a great stain? And then they can share their advice, and it might improve all of our students' work. It might even be helpful procedurally for us to improve our procedures. So this is something that I'm actually really jazzed about. That being said, let's take a minute to go through the TA guidelines for both Labs 7 and Lab 8 so that we can see some of the details of what's up and coming on first Tuesday and then on Thursday. One of the notes that I want to make for the Lab 7 Tuesday lab is that this Friday I had to go through the plates, and I split your salt plates into a special bin. I also split your T-streak plates into a separate bin so that they could grow for 48 hours. The salt plates have to go for longer than 48 hours. So we're going to have to find the plates from their varying locations, and you all can help me with that. Making sure that we do pull the temperature plates out of their respective incubators, get the salt plates out of the 37-degree incubator in a special bucket in there. So we just have a lot of accumulating to do when we get started on Lab 7. I'll pull up the TA guidelines for Lab 7, and there's a couple of other things that I want to make note of on that. First off, students will be turning in their Pipette Man tutorial during this lab, and so again, there is a key for the Pipette Man tutorial on your jump drive, and that is another thing that we'll be looking towards grading. Once again, just a very simple thing to grade. So we may want to think about splitting that up. Most of you have 3 TAs in a section, and we probably want to split it up amongst you, the grading. Please do make sure, however, that the TAs that have been notified of a stipend are doing primarily all the grading. That's important. We also do want to get the students restreaking for isolation today. That is sometimes overlooked in the procedure if we don't point that out to them. And the other note is I want to make sure that they understand that there's a difference between the Micrococcus luteus colonies and the Staph aureus colonies. So pulling their attention to the smaller yellow colonies as Micrococcus and the larger white ones being Staphylococcus. Also pulling their attention if they don't seem to have 2 colonies, showing them that they really only got 1 there. I also want to make note about the lecture. This is a lecture that I often do. It's the bioluminescence lecture. It goes pretty into depth in biochemistry. So I would make note that it would be best if someone who has a biochemistry background can give the bioluminescence lecture. It also goes into a lot of physiological stuff regarding the relationship, the symbiotic relationship between the squid and the bacteria. But I think that's a little bit more straightforward than the biochemistry. So again, have somebody with biochemistry background give this if someone else is giving it. Also bear in mind that I can give it. Also bear in mind that I can give parts of it. We can tag team it. So if you want me to give the beginning biochemistry part, then you want to talk about the symbiotic relationship, that sounds rad. And I would be more than happy to tag team it with you. That always works really, really well. However, on the note of the biochemistry, I wanted to dork out a little bit with that, and I went ahead and on your jump drive in the publications folder, you're going to find this article that talks about the reaction mechanism of luciferase. And this is an interesting reaction mechanism because for years I've been talking about the reaction mechanism, but not really recognizing the details of how it takes place. And it's interesting to note that in fact the flavin mononucleotide acts more like a substrate. Its typical role would be as a prosthetic group, right, a coenzyme, but in this particular case it acts as a substrate. And so here's the mechanism. I'm actually going to read to you some of this. Bacterial luciferase catalyzes the production of visible light from the reaction of flavin mononucleotide, molecular oxygen, and a long-chain aliphatic aldehyde. The first step of the chemical transformation is the formation of a C4A flavin hyperoxide from the reaction of the flavin mononucleotide with molecular oxygen. So this is of note. The first reaction is between flavin mononucleotide and oxygen, O2. And this forms a stable intermediate in the presence of the enzyme, and it can actually be isolated. That intermediate can actually be isolated. Then what happens next is that the aldehyde reacts with this, and it's thought to form a predicted kind of transition state at that point, or intermediate, but it's not been isolated at all or characterized. But what happens is the decomposition of the hydroperoxide is this hemiacetyl adduct then generates an excited state, an intermediate that emits a photon of light, and that's the source of the light. So let's look at that in pictorial form. So here is the reaction product when oxygen reacts with the flavin mononucleotide, and this creates that detectable intermediate. But then further interaction with the aldehyde then generates, again, the predicted compound that emits the photon of light, which is what we're seeing in this step. So just to dork out a bit, I thought a lot of you would enjoy that, especially those of you who took biochem with me this summer. So yeah, cool. Wonderful stuff. Let's go on and just look at the TA guidelines for Lab 8, but not before I mention the Winogradsky columns. A lot of students are super jazzed about these, so I want to make sure we give due time to the Winogradskys. So that being said, while I want to give justice to this lecture, I also don't want to overdo the lecture to such a point that we don't have time for them to build their Winogradsky columns. I want to make note of the Winogradsky columns. I'm going to draw a picture on the board about them. I want to make sure that they feel like due justice is being given to those columns. Okay, let's look at TA guidelines for Lab 8. And just to take a moment to run through those, this is a straightforward lab. Even though there is a large lecture, the lecture is straightforward. And a lot of the concepts I trust you all to take time to learn and to already be fairly familiar with. The formation of thymine dimers and whatnot. It was actually fun. One of my skiers who's taking the class right now, Britta, she's in Callie's lab, I believe, and Sydney and Jesse, she was asking me about what happened when I had the UV pen out. We were, this morning we went on a really long run with the ski team and we had the UV pen out to sterilize their water when we got fresh water. And it's rad that she then asked me what that UV light does to cause damage to the bacteria. And so this really fits in nicely with what we'll be talking about here. We'll also be looking at antibiotics and enjoying a discussion on their mechanisms of action. This will be the first exposure they've had to antibiotics, so we want to do a good job of explaining that slide about mechanism. So that being said, just one thing to note here is that I really think that the concept of selective pressure is super, super, super important. So make sure you do a good job of explaining what selective pressure is. The idea that something that can live in the presence of streptomycin already had a mutation. It already was a superhero. But when we put it in the presence of streptomycin, suddenly it can live and others die. And this is the idea of selective pressure. So very important. I think that wraps up our coverage of the TA guidelines. And I think I managed to get to most everything, except for that I want to spend just a second talking about a couple of new things on Canvas. So I'm going to pull up Canvas. And this is actually going to address, in one note, something that Andy asked about. In another, something that I just think is a good time to start thinking about how our students are doing and maybe checking up on some of those who haven't done much. So you'll notice that when you're in the main page after you've gone to my course, you over on the right-hand bar, there's something called View Course Analytics. And if you click on this, it's going to give analytics for each one of your students. You're going to be able to scan down. Right here, this is full class data that you're seeing, but you're going to be able to also scan down on this, and it will give a list of students so that you can actually take a look at what individual students have been doing. I'm not going to pull that up because I don't want to show student data on here, but I want you guys to take a moment to look at your analytics so that you can see how each of your students are doing. That is to say, are they not turning in the pre-lab? Is there someone we need to talk to because they haven't turned in a single pre-lab at all? The other thing that I wanted to show you, and this derives from Andy's question, is I want to show you the calendar. So you'll also notice over on that right-hand side, there's a button that says View Calendar. And we can make changes on this calendar. So we can actually use this calendar for reminders of things that are up and coming. And you can note that this already does show due dates, for example. So this is something to keep in mind and recognize as a feature that maybe even for us as TAs and instructors, that this may be a really useful feature, adding things to the calendar. So you can actually add events onto this, Andy, and this could be a really fun way for us to accomplish what you had asked about the other day. So have a fantastic rest of your Sunday, and I can't wait to see you all on Tuesday.